Welcome back, Algebra 2 students. Today we're going to look at solving equations with absolute value. So we've talked a little bit about what absolute value is. We've talked about the definition. We've talked about the graphs and the transformations. So today we're going to use what we've learned and solve equations with absolute value. And then in the next video, we'll look at actual application, like if you have a situation with a word problem and a situation where you need absolute value, how do you write that equation? But let's look at how to solve them. First, let's think back to the definition of absolute value is the distance from zero on a number line. And I guess we really don't even need that and on a number line part, but definition of absolute value is the distance from zero. So if I have absolute value of 4, it might be 4, but it also might be negative 4. Because if you have here's 0, both of these numbers are 4 units from 0. Okay? So both 4 and negative 4 have an absolute value of 4. Okay, so if I have the absolute value of x equals 3, what can I put in here that would be 3 units away from 0? If I start from the 0 and I go 1, 2, 3, but I can also go this way and go 1, 2, 3, right? So x might be 3, or x might also be negative 3, because both of those numbers are 3 units from 0. Okay, if I had absolute value of x equals 1, this number is 1 unit away, and this number is 1 unit away. So x might be 1, or x might be negative 1. Because of that absolute value, we're looking for how many numbers are 1 unit away from 0, or how many numbers are 3 units away from 0. And you have two choices. Think about your graph. Okay, if this is your axis of symmetry, so this is a 0, this number and this number are both the same distance away, right? So that's absolute value. So what does that mean when we start to solve an equation? So let's say if we have absolute value of x minus 4 equals 3. Okay. So whatever this quantity is, whatever this value of x minus 4, it's 3 units away from 0. Okay, so if we think about a number line, if this is 0, we have 3, and we have negative 3. Both of those numbers are 3 units from the 0. So this x minus 4, whatever this quantity is, might be 3, might be negative 3. So if I need to know those possible values for x, I'm going to add the 4 here and add the 4 here. So these two values, x equals 7, x equals 1, give us an absolute value of 3. Let's check it. If I take this and plug it back in here, what is 7 minus 4? 7 minus 4 is 3. What's the absolute value of 3? It's 3, so that one works. What about this one? Absolute value, take this 1, plug it in for the x. So I've taken this 1, plug it back into this equation, replace the x with 1. 1 minus 4 is 3. 1 minus 4 is negative 3. What's the absolute value of negative 3? In other words, how far from 0 is negative 3? It's 3 units. So this one works. So both of these are valid solutions. Both of those make that equation true. Okay. Let's try another one. Find absolute value of x plus 2 equals 6. How many units away from 0 are we talking about? We're talking about 6. 6 units away from 0. What two numbers are 6 units away from 0? 6 and -6. So this quantity of x plus 2 might be equal to 6, or it might be equal to -6. I do that every time. Now we're going to treat these as two separate equations and solve by subtracting the 2, these two numbers. Right? Those two numbers, if you replaced x with those two numbers in the equation, you would get an absolute value of 6. Let's try it. So in case you don't trust me, I took this 4 and I plugged in for this x. 4 plus 2 is 6. What's the absolute value of 6? 6. Take this -8, plug it in for this x. What's -8 plus 2? -8 plus 2 is -6. The absolute value of -6 is +6. So plugging in 4 for x or -8 for x gives us an absolute value of 6. That's the concept of an absolute value equation.